Most valued student, my name is Confident. Welcome to our last session of the Mathematics N3 revision, and this is the paper that was written in November 2011. Yes, this is an old paper. As I said, it was written in November 2011. In as much as this is an old paper, I did mention that sometimes you discover that the people who set these questions, they usually go back to their bank and they at times bring even identical questions, especially in this 2021 going forward. They go back to their exam banks and these questions are recycled, and it is also important therefore for you to go through such revision sessions so that you can be in a way updated with curriculum. Now let us look at this question paper. I think we have done most of the questions. We started with question number 1, and if you have not done so, I would therefore encourage you to go through the previous videos that did look at all these questions. We did question 1 and we analyzed it, came up with some solutions, and then we went on to do question number 2. We also analyzed it and came up with some suggested solutions, and then we went on to look at question number 3. And yes, we did question number 3. Also, you need to look at the video that is talking about this question number 3. We worked on it to sketch some graphs, and also went on to look at question number 4. I think question 3 and 4 were combined. And then yes, we looked at question number 4, analyzed it, and then lastly, it is now for us to look at question number 5, which this section is about looking at question number 5, and it in a way completes the whole question, as you will see that this is the last part of the question. Now, without wasting time, and just before I start, guys, as I said, remember to subscribe. It is important, very, very important, guys, to subscribe to our channel. Time and again, we're seeing a very big increase in our channel subscriptions, and you see, the more you guys are subscribing, you are actually giving us the motivation to say there are people out there who are benefiting from this channel. So subscribe to our channel so that we might be even more motivated to bring you these videos at no cost to you. So it is the appreciation that you can just be doing just by pressing the subscription button, as well as turning on that notification bell so that you can be notified by YouTube every time there is a new video that we're posting. We post quite a lot of videos on different grades, so you don't want to miss your own grade. So whenever we are posting a video, you will always be notified in real time the moment we post it. If you turn on the notification bell, you are already notified immediately there is a new video. And also, if you want some resources for Mathematics N3, and we have a textbook which is Mathematics N3 for the underdogs, you can also use that textbook for your revision or for your learning. Let's say you are starting your math N3 and you have, in a way, you don't have even a basic foundation, and you want to get all the basics and all the information that I'm using as I'm teaching or as I'm revising with this paper. All that is based on the Maths N3 textbook. It also comes with videos. You can purchase it online. The book can be found on Take-A-Lot, and once you buy the book, you also qualify to have or to be registered in our online videos, because the book comes with videos. So after you purchase it, you will also get the book access to the videos, so that you can link the book together with the videos. All right, enough about that. Now let us look at our question. As I said, we are starting with question 5.1. It's mainly question 5 is on trigonometry. Say simplify to one trigonometric ratio of x. So this is 3 marks. So we are given sin 360 minus x. If I can write this on a new page, it's sin 360 minus x. So I have, in a way, this is sine or sin 360 minus x. I think it was a dot, sec 360 minus x, 360 minus x, and then I think that is a division line, and then we have 10 180 minus x, alright, also multiplying cosec 360 minus x, so cosec 360 minus x. Okay, so this is what we have. So now what I need to do, as I said, it says the question is simplify to one trigonometric ratio of x. So they need you to simplify this to x. And whenever I'm solving these, I usually emphasize with my students to say, ensure that you have your cast diagram, and that is what I'm going to use mainly in all of my working in this trick. So let me quickly have my cast diagram here so that I can use it as my reference. And as I say, I always encourage the cast diagram. So remember, we have 0, 90. This is my 90 part, and we have my 180, 270, and 360. Now you need, as I said, all this information is covered in the books. So with that, we have got all students take chemistry. So we have all students take chemistry, and in here we have got, in a way, the reduction rule for this is 90 minus theta, or 90 minus x. In this case, we have 90 plus x, and we have 180 minus x. We have 180 plus x, and we have 360 minus x. And then we have, as I said, all students take chemistry. So this is the main trick, what you call the cast diagram that we say. As you can see, CAST, the cast diagram. Now, how do I solve it? Let's start with, I've got sine 360 minus x. So this continues to give me, so where there is sine 360 minus x, I'm looking in the fourth quadrant. As again, just to write, this is my first quadrant, this is my second, this is my third, and this is my fourth quadrant. So now when I look at the fourth quadrant, that's where I have 360 minus x, and you can see only cos is positive, sine is negative, and tan is negative. So if only cos is positive, so and sine is negative, my reduction rule therefore become minus sine x, put that in brackets, remember it's very important, times, now sec 360 minus x is also 1 over cos 360 minus x. You leave it that for now, you come back to that. Also you can leave it in brackets, all over 10 180 minus x. I can actually simplify tan, and 10 is 180 minus x. It is in this quadrant, which is quadrant number 2, and only sine is positive, which means 10 is negative. So I will have minus 10x is simplified, and then times cosec is 1 over sine 360 minus x. And I think you can get this trick if we go to our formulas. You will find, I think there are formulas. under trig, you can find sine. You can see there is sine as 1 over cosec, and cos is 1 over sec. So you can use this. So the opposite is true. If sine is 1 over cosec, which means cosec is 1 over sine. Cos is 1 over sec. Sec is 1 over cos. So you can use those also as a reminder. But you need to know this from practice. So now when you've done that, we can continue quickly to simplify this, and this will just become minus sine x. Remember, now we have to simplify our 1 over. Now cos 360 minus x, this is quadrant number 4, and cos is positive, and we are also dealing with cos, so there is no change in sign, so it is cos x, saying that over. Now 10, I need to convert 10 to let me just check again if we have it in the formula. 10 is, yes, we have it. Remember, what is 10? 10 is sine theta over cos theta, so I need to convert 10 there. So I will have here minus sine theta over cos theta, that is my 10, and then remember at the bottom it's times. Now sine 360 minus x there, I'm supposed to use x, not theta. This is supposed to be x. Alright, so this is x, this is x. Alright, now cos 360 minus x, and in here I'm saying you're going to use 360 minus x. You see, this is the quadrant, only cos is positive, which means you have, if it's sine, it's negative 1 over sine x. So like that. So this is what I'm having. Then the next thing is just my algebra part, where I just have to know how to simplify that. So what I have, this is like over 1. If ever you're simplifying sine, it's over 1. So the top multiplies and the bottom multiplies. So it's minus sine x times 1. We are going to have minus sine x over 1 times cos x, which is cos x, and then you have the bigger division line. You come here, you can see that the sine cancels with the sine. You can see that cancels. The negative, we have got 2 negatives, so they neutralize to become a positive, so that becomes positive. So this is 1 here, 1 times 1, you have 1 on top, over, and then cos, and this also becomes a 1, so cos times 1, so the bottom multiplies, the top multiplies, cos times 1, we have got over cos x. Alright, so this is how you simplify. So how do you finalize that? So this is like saying minus sine x over cos x divided by this division sign. I'm changing into divided by 1 over cos x, which is equal to minus sine x over cos x. You convert division to times, you take cos to the top, you take 1 to the bottom, which is cos x over 1. You seeing that? So when you do that, the cos cancels the cos, and then again what you have on top is a 1, and then at the bottom is a 1. So what you're saying is minus sine x times 1, which is negative sine x, and then 1 times 1 at the bottom is 1. So the answer there is negative sine x. So that is what is the final answer to that. You can quickly test this by what you can simply do to test it. You choose any value of x and say let x be equal to maybe say any number, let's say 20 degrees. Let x be equal to 20. So you put the value of x here, you put 20, you put 20, you put 20, and you put 20. So if we do that, though bearing in mind that sec is 1 over cos, so you have the bigger fraction, which is sine 360 minus 20, and then you've got times sec, remember, is 1 over cos. You don't have sec, but you can do 1 over cos, and then you've got 360 minus 20. All right, and then you got down to 10, 180 minus 20. This is just to test if ever your answer is correct, times cosec is 1 over sine 360 minus 20. So here you're just trying to check if your answer is correct. You can see I'm getting negative 0,342, so that's what I got, negative 0,342. So I take that answer, keep it in mind, go back to this side of my sine. Remember my x, I said let my x be equal to 20, so that here there is 20. So I test also this side where there is x, which is minus sine 20, and check if it balances, which is negative 0,342. So if you look at this answer, negative 0,342 here, and you compare to the one that I just got, which is negative 0,342, you can see that it matches. So when it matches like this, it means what you started with is still balancing with what you end with. So your simplification in this case, it becomes correct. So that is what I use just to make sure that I didn't make some errors. All right, so let us look at the next one. Having done the first, we can now look at the next question, and the next question is also looking at, so we're done with the first one, is looking at, it says 5.2 here. Simplify by making use of basic trigonometric identities, and 5.2.1 is sec theta minus tan theta times sine theta. So if I also come here, I'll need to just to clear my space here. All right, I just want to clear this because I want to continue with my cast diagram. So if I have to continue with the cast diagram, I don't want to keep on doing it. As I said, it is very important for you to keep maintaining your cast diagram because it helps you to simplify such things. So now let me look at in this question now. It says sec theta minus tan theta sine theta. So if I have it here, it's sec theta minus tan theta sine theta times, it means it's multiplying. So this is what I'm having. So now how do I simplify? Remember, sec is 1 over cos theta, that's the first part, minus tan, you convert tan into sine theta, over cos theta, we have dealt with this, multiplied by sine theta. So now it doesn't matter how you write it. Someone will say, but what if I write it like this? You can write sine theta there, but you must know in this case that this way of writing is the same as sine theta is on top, so it is over 1. You must always know the two are always multiplying like that. So it's sine theta times sine theta. So what I will have therefore is 1 over cos theta minus sine theta times sine theta is sine squared theta over cos theta. So the common denominator symbol there is cos theta. You can see that. Now cos theta into cos theta is 1 minus cos theta into cos theta times sine squared theta is sine squared theta. So that's what you'll be having at the top, and it's very important one to notice Now if I go back to the formulas that we're looking at under trig, there is an important formula that you always need to know. I always emphasize this formula, and it is this particular formula, which is sine squared theta plus cos squared theta is equal to 1. You remember it? Sine squared theta plus cos squared theta is equal to 1. So I'm going to bring it here to say but sine squared plus cos squared theta is equal to 1. So now I can write this formula in different parts so that it matches this top. Now how can I make it match the top? I can take sine to the other side. It will be, in this case, cos squared theta is equal to 1 minus sine squared theta. So you see I have now sine squared theta. So where there is sine squared theta, now I need to put that cos squared theta. So I will have in here cos squared theta divided by cos theta. Now cos squared theta divided by cos squared theta, they are 2, so 1 will remain, and the answer simple becomes here cos theta. That's how this thing simplifies at the end of the day. And as I said, you can test it, choose any value. So here, if I choose any value, for example, if I say let x be equal to 12 degrees, so where there is theta, you put your 12, you put your 12, you put your 12 in the beginning, and put your 12 in the final. The answers must match. So you come here, sec is 1 over cos 12, and then minus 10, and then it's 10 12 times sine 12. So if I do that, I'm getting 0.978. So I'm getting here 0.978. I need to get a similar answer when I input the value here where there is cos. If I put a 12, so let's try that, I need to get 0.978. So if I say cos 12 is equal to, you see, 0.978. So such is the thing I use to get that confidence to say, you know what, I'm not guessing this thing out, but I'm solving it in a way that is consistent. Alright, so that was 5.2.1. Let's look at 5.2.2. I need to simplify 1 minus sine theta, 1 plus sine theta over cos theta. This one is 2 marks. The previous one was 3 marks. So if I also do that, as I said, I want to maintain my space here. So if I just keep that for now, and let's look at this question. And this question is saying 1 minus sine theta multiplying 1 plus sine theta. So I have in bracket 1 minus sine theta multiplying 1 plus sine theta all over, and then at the bottom I have got cos theta. It's 2 marks, meaning it's not very far. So if I've got this, now how do I simplify it? You know, this one takes you, there are different ways you can use this, but by recognition already you can actually say the answer. But I can take you back into this question here, or into this expression. Now let us look at our expression that I did here. Remember we said sine squared theta is equal to cos squared, sine squared theta plus cos squared is equal to 1. Now this I can move on to say cos squared theta is equal to, this is a difference of 2 squares, where that you square, then you put your brackets like this, and then you say this is, start with the negative 1 minus sine theta and 1 plus sine theta. So you actually see that this is actually cos squared theta. So I can come there without doing much and say this is simple cos squared theta over cos theta Now do the same thing, cancel cos. Now there 2 is 1. The answer simple there is cos theta. You can just do that without doing much. But someone will say, what if I chose to open this bracket? For example, what if I chose to multiply like that? Still the same thing. You multiply like that and you open that bracket like that. Let's do that. It would have been equal to 1 times 1 is 1. 1 times 1 plus 1 times sine theta is sine theta, minus sine theta times 1 is minus sine theta, and then minus sine theta times sine theta is negative sine squared theta. So you see, plus sine theta minus sine theta, it goes, and then you've got 1 minus sine squared theta, and we did get this to say 1 minus sine squared theta. Remember, we did get it there. It was 1 minus sine squared theta. So you see, at the end of the day, it will lead you to that. So you can test it again. Put your theta here. Choose any value of theta. For example, you can say let my theta be equal to 55 in this case. So where there is theta, you put your 55. You put your 55 and you put your 55, just to be more sure. So you've got here in bracket 1 minus sine 55, and then be careful of the brackets there, because one opens, one closes, so you must put 2 brackets there, and then you open another one, which is 1 plus sine 55, you close and close, over cos 55. Be careful of your brackets. It's 0.5735. Just look at this one. This number 0.5735. If I look at the cos 55 again, cos 55, my final answer, it's 0.5735. You can see that this is matching. I didn't want to spend much of it, but that is how simple that thing can match, and your answer is actually just like that. So let us look at the next one. The next one, it says here 5.3. So we are moving on. Says calculate the exact value without using a calculator, and then you're given that, and then this 4 marks. So now let us look at that. Actually, the moment they say don't use a calculator, what you do, that's when I actually use a calculator. But let me write it down first. It's sin 150 here. See, back I need now my cast diagram, which is handy. So what I have here is sine 150 degrees times, and then I've got cos 330. All right, and then I've got minus tan 240. All right, and then this is all over. I have minus cos 210 210, and then I have minus tan 120, so it's minus 10 120. So this is what I'm having. Let me just cross check. Sine 150 cos 330, 10 to 40, sine 150 cos 10 minus. All right, so this is what I'm having. As I say, the first thing you do when they say don't use a calculator, you need to take that calculator and find the final answer so that you can work towards that answer. So we've got sin 150 times cos 330 and minus tan 240 all over minus cos 210 minus 10 120. So this is what I'm having, equal to, the answer is minus a half. So you see, I just need to get here a negative 1 over 2. negative 1 over 2. Let's just keep that in check. That's where I'm working towards to. So now if this is what I'm working towards to, then I need to, you don't need to guess your way. You need to know, okay, this is what I'm working towards to. Let me prove that answer. That's what you actually are doing, especially with such. So let us look at it. Now you look at sine 150. So you say sine. Now where do I find 150? I find 150 in quadrant number 2. It's between 90 and 180. That's where I'm getting 150. So that's where you get your 150 here. So if I'm getting my 150, what is the reduction rule? I will prefer to use this one for 180 minus x. So what I'll write here is sine 180 degrees minus. So what number must I separate from 180 to get 150? So if I separate the two numbers, 180 minus 150, you see that it is 30. If I separate 30 here, it will give me that 150. So that's what I'm doing. Now what about cos 330? So it's cos 330 is in this quadrant, and the reduction rule, you can see, is 360 minus theta. So it's 360 minus, so if I look at the two numbers, 360 minus 330, it gives me 30. So if I separate 360 minus 30, it will take me back to cos 330 minus 10, again 240, which is in quadrant number 3. That's why I'm getting 240. So it's 180 plus, now I need to again separate the two numbers, which is 180 minus 240. Don't worry with the sign, just I'm looking for the number, which is 60. If I say 180 plus 60, I'm getting 240. You see that? And then I divide that by, in here, over, now minus cos, now 210, it is again 210. Actually it's in this quadrant, this is where I get 210. So it is in quadrant number 3, so it's 180 plus, subtract the two numbers of 210 minus 180, just to get the other number, which is 30 degrees. Alright, so that's what we are having. And then minus tan 120 is in quadrant number 2, and this is, I'm going to use 180. I usually start with 180. You can still use 90 plus, it's fine, but I usually use 180. So it will be tan 180 minus, so if I use 180 minus 120, it gives me 60. So that's what I'm having. So at this stage, I then use my reduction rules again further to reduce that. So sine 180 minus 30, as we said, it's in the second quadrant, and that's where you get 180 minus, and sine is positive, so the first one becomes sine 30, and then multiplying, and then cos 360 minus 30 is in that quadrant, and cos is positive, so it's cos 30 minus tan 180 plus 60, which is in this quadrant, and 10 is positive also, which is tan 60. All right, so I don't need to put in bracket, it's just that, all over, minus cos 180 plus theta. Again, cos is in the third quadrant, but cos is negative, so it's minus cos 30 minus, now tan 180 minus 60 is in the second quadrant, and 10 is negative. Again, it's got minus tan 60. See that? So when I've done this, I just now need to finalize, and it's up to you how you do it, but you have to now use special angles. And these special angles, you are allowed to use at this stage your calculator, because special angles, in a way, you can actually use a calculator to solve them now. So I can now say, what is my sine 30? So my sine 30, I can now put, you see it's a half. What about my cos 30? My cos 30 is root 3 over 2. So I've got 1 over 2 on top, and then I've got root 3 over 2 minus, then I look at tan 60. So in as much as they are saying no calculator, but at this stage you can claim you know these special angles. That's why they are called special angles. But you can actually prove this with a special angle triangle, but they don't check that. They allow you won't lose marks to what I'm keep doing now. So you put a negative becomes positive. It's cos 30, and this is matching. So we said that was root 3 over 2. So I put there a root 3 over 2, again minus, and minus is a positive. It becomes tan 60, and tan 60 was root 3. Alright, so this is what we have. Then the matter here that is left with is for you to simplify this. So remember, these are multiplying on top and they are multiplying at the bottom. So it's 1 times root 3, which is root 3, over 2 times 2 is 4 minus root 3 over 1. You see that then this, I'll change it to this divided by, but put a bracket after that because you need to protect that negative. And then you've got root 3 over 2 minus root 3 over 1. See that? That's what in a way I'm having. But also I'm actually checking something here. Let me show you this. Let me not do this first. Actually, it's interesting to say over. If I can continue with it here, it's root 3 over 2 minus root 3 over 1. I think if I continue there, it's actually already much. Let me see if ever that's what I'm seeing. If ever this can simplify. Fortunately not. What I was thinking is not what I'm seeing here, but what I can do, let me take it back. I thought it could simplify much easier there. So let's take that back using the division sign in that version. So that's what I'm focusing on now. So now it's fractions that you need to do. So the common denominator on this one is 4. So 4 into 4 times root 3 is root 3 minus 1 into 4 is 4 times the top, which is root 3, divided by, here it's the 2 into 2, it's 1 times root 3, minus 1 into 2 is 2 times root 3. So this is just that. Now you must convert this into a times. So it's root 3. You can factorize. Let's factorize root 3 on top there. Root 3, which is 1 minus 4. I hope you can see that. I'm taking out root 3. So root 3 into root 3 is 1 minus root 3 into 4 root 3. That over 4. Now, instead of divided, I've changed to times. This goes to the top, that goes to the bottom, but I'm also factorizing, which is 2 over root 3. And with that, root 3 into root 3 is 1 minus root 3 into 2 root 3 is 2. See that? So when you do that, you can now say root 3. So it's root 3. 1 minus 4 is minus 3 over 4 times 2 over root 3, and 1 minus 2 is minus 1. I think you can see that now. So when you remember this, the top multiplies and multiplying, So in a way, you are simply having here root 3 times minus 3 times 2 over 4 times root 3 times minus 1, so that you can see that this simple cancels that, and the 2 into 4 goes 2 times, and the negative sign will neutralize the negative sign, so that what we have on top, we've got that I think I'm having a 3 here, so it is 3 if I'm not mistaken here. Am I right? Is it 3 over 2? Am I right there? Because there is a 3 remaining and there is a 2. But now let me check again my answer and see whether this matches. But my answer gave me a half, so somehow I think I might have misplaced or done some of the things wrong. So let me check again if everything is done properly, especially when I was changing here. That's where I need to check here. So it was 1 times that, which is root 3 over 4. Okay, another thing that I can do actually at this stage is to take my calculator quickly. And what will I be doing with the calculator? I want to use my calculator to check if my answer at this stage is still maintained as that half. So I can take my calculator here and say that is root 3. That is another way just to check if you are still going to get that negative half. So it's root 3 over 4 minus it's just root 3 over 1, which is root 3. Close the bracket, and then say divided by, just to see whatever we are doing that is still on track. Root 3 over 2, then it's minus root 3. So if you check this, it helps you to see, are you still getting a negative half? You see, this is giving me a 3 over 2, so obviously the error was already made at this stage. So anything from here, it means there is an error. So I need to go back here just to see again. This is where you're tracking now to say where might I have lost it. So you come here back again, start from this sign, you can check now to say what is sine 30. So I have sine 30 and then times cos 30, alright, minus 1060. Sometimes you can use it before you make all these errors. You can even go down with it like that. Every time you do a stage, you check with your calculator, but you know, sometimes you'll be trusting that you're doing the right thing. But to avoid such, you can keep on testing that it gets you to the first answer that you got, 1060. I hope I'm having it right there. There is somewhere, so it's minus bracket, so I'm supposed to close that bracket there. So you see, at this stage I'm still getting a half, so it means my half is still fine here. So things then went wrong at this stage. So let me try back and do the right things from here, or just to show you how you can check your error. What you can do, you can even actually already see where the error is. This is where the error is. Look at this. So that's how I picked it up also. Look at this part. I had two negatives here. I said a negative and a negative neutralizes to a positive, but when I got down here, see, I never changed my negative. I maintained it as a negative, but this is now supposed to be a positive. So that's where things started changing, because if I now look at it, this is supposed to be a plus now, So that's why it was good that I didn't change that. This is supposed to be a plus, and I think the answer might come out now, because everything where there was a negative here, it's supposed to be a plus. So you see that? So if I can then work it from here, I'm not removing this so that you can see how I detected my error. So I'm starting from here. So it's root 3 1 minus 4 over 4 times 2 over, remember there is a plus, now it's root 3, it's 1 plus 2. See that when I change that, and then I've got root 3, I've got minus 3 over 4 times 2 over root 3, and then I've got 1 plus 2 is 3. So that is where things were now going in the wrong way. So now, as I said, you are multiplying root 3 minus 3 times 2. Just doing exactly what I did. It was just an issue of sign there. Root 3 and then 3. So when I do that, look at it now. I have got root 3 cancelling the root 3. Let me use a different pen. Root 3 cancelling the root 3. I've got the 3 cancelling the 3, leaving us with a negative 1 there. Don't forget that negative. The 2 cancelling the 4 to give us a 2. And then my answer there will become on top. Remember, it's 1 times minus 1 times a 1, which is negative 1 over 2 times 1 over 2. This is the answer that I'm getting. And if you still remember, that is what we simplified as negative half. So you see that it was going to be that, provided I ensured my sign that change there. So that happens at times, but in a way you need to keep yourself in check. So that is a 4 marks. We are done. We are looking now at 5.4. Says calculate the values of x that will satisfy the following equation, and then you are given this: 0 is less than or equal to x, x is less than or equal to 360, and then you are given 2 sec x minus 5 is equal to 0. So now I need to work on this question again. I'm going to maintain my cast diagram, and I'm not going to take out everything. It might need a small space, so I'm just going to do this, leave everything down there. I don't think I might use all of it. So let's look at this space here that I'm given. I'm saying the question is, we are given 0 is less than x. So it's if I write it down, it's 0 is less than or equal to x, x is less than or equal to 360. That is my values of x are between that. So I'm supposed to solve 2 sec x minus 5 is equal to 0. So it's 2 sec x minus 5 is equal to 0. So next, first things first, take 5 to the other side. We have got 2 sec x is equal to 5. Are you seeing that? And then it's up to you how you do this. It's very open. Now I can divide by 2 first. Divide by 2, you can see that sec x is equal to 5 over 2. Now when I've done that, remember now with sec is 1 over cos, so you change or convert sec as 1 over cos x is equal to 5 over 2. It's up to you how you do it, but there is a simpler way at this stage whereby if it's fraction versus fraction like that, what you can do, you can invert one side, and what you do on the left you do on the right. So if you invert like this, so say cos x over 1, what you do the same. 2 goes to the top, 5 goes to the bottom. You've got 2 over 5. It's allowed. So cos x is equal to 2 over 5. This is algebra. It's up to you how you do it. You can simply cross multiply there to say 1 over cos x is equal to 5 over 2. You cross multiply, or yes, cross multiply, cos times 5, which is 5 cos x, is equal to 1 times 2, which is 2. Divide by 5, and you've got cos x is equal to 2 over 5. Whatever case, you're just going to get cos x is equal to 2 over 5. Now, how do you find your x? Therefore, you're going to say x is equal to arc cos 2 over 5. That's how you find your x there. So this is where you use in your calculator to say my x is equal to, in this case you use your arc cos 2 over 5, shift arc cos 2 over 5, that, then it gives you 66,4218 to 3 decimal places, 66,422 degrees. Then we call this, it's a ref, your ref angle is that. But now they say to you the values of what? The values of x is between 0 and 360. So what you do is, since your x is positive here, you can see you got the first value which is positive, so you ask yourself which other quadrant is cos positive. So you go to your cast diagram and you will see that cos is positive also in the fourth quadrant. There is C, cos is positive, and in the first quadrant is 360 minus x. So what you're going to do, you're going to say or, that's the second answer, or x is equal to 360 minus a ref angle, which is equal to 360 minus 66,422, and then you will get now your other angle there, which is 360 minus 66,422, and then it gives you 293,578, 293,578. So this is the two values of x. You can test them if you want. So what you do, remember they are saying 2 sec x minus 5 is equal to 0. So that you get your real 0, you say arc cos 2 over 5 here, so that you get the rounded off figure. Remember we said shift arc cos 2 over 5, and this is what I actually got. So you take this whole number, you put it in the first one. It says, remember this, if I say answer equal to, this is my answer. So if I say 2, now sec is 1 over cos, so 2 times, put that as 1 over cos, then you say cos answer, you see that, and then you say minus 5, it must give me a 0. See, it's giving me a 0, so this is correct. The other one, I'll say shift arc cos 2 over 5. I got that answer. Remember I said 360 minus that answer. Now this is the other version of the answer, so I do the same thing. Remember it will maintain, my last answer will always be maintained. So I'll say 2 times sec, remember it's 1 over cos, 1 over cos, answer, remember it's minus 5, it must give me a 0 again, so which means my two values of x are correct. That is what then you justify your answer being that or that. Remember there must be two answers using a cast diagram. And then okay, we are moving on, we're done with that part. Then let's look at the next slide, and I think we're about to finish. This is question 5.5. Says in triangle, while looking at this part here, it says in triangle ABC, A is 33, so you see that A is 33 centimeters, B is 27, and C is 21. And then, okay, that's what they're giving me. And then here they say calculate the following, the magnitude of A by using the cosine rule. This is 3 marks. So I think if you come to these your formulas, you have the cosine rule under trig, and this is the cosine rule. So you see this is the cosine rule. And now with the cosine rule, they say they want the magnitude. If you look at this, they are saying the magnitude of angle A. So if you look at it, they are saying here, find the magnitude of angle A. So in other words, what they are asking is, in this particular diagram here, triangle ABC, they want that, actually not the one, they want this angle A. So that is what you are solving. So you are using the cosine rule. They specified, they said using cosine rule, so you don't have a choice. They give you 3 marks. So if I go to my formula, now you need to, I'll do it here, to convert this formula in terms of cos A, make cos A the subject of the formula. There are simpler ways you can do. You can see this formula already, the negative is this side. So what you can do on this formula, you can make it bigger. As I say, the aim is to make this negative part, this negative, there is an equal sign. So take the negative 2b, 2bc cos A the other side. So you'll have a positive 2bc cos A is equal to, now the A squared comes this side. So you'll have b squared plus c squared. Now the a squared was positive, becomes minus a squared. So you divide by 2bc, you divide by 2bc. You see that? So you'll have now your cos A being, cos A is equal to, then it will be this part of b squared plus c squared minus a squared over 2bc. This is what I need to use that side, that cos A is b squared plus c squared minus, I think I can write that, which is here. I can actually write it here to say cos A is equal to b squared plus c squared minus a squared over 2bc. See that? And then which is equal to, that is my cos A. Now my b is 27 squared, my c is 21 squared, my a is 33 squared over 2, and then times b is 27 times c is 21. Now my a here is equal to arc cos this whole thing. So if I'll get an answer here that I'm going to put there, so it's arc cos that, I'm not going to do it twice, then I can actually find the answer once. So what I can do, instead of writing this, say 27 squared, I can automatically say shift arc cos, then I write this of 27 squared plus 21 squared, because that answer will say arc cos. Or I can first with my calculator do what I did there, to say 27 squared plus 21 squared minus 33 squared over 2 times 27 times 21. I hope I'm doing this correctly there. So which is equal to, you see I'm getting this answer, then I'll say shift a cos answer, which is 1 over 14. Then it will give me 85,9039, which is 85,904. So it's 85,904 degrees. So that's what I have here. A is 85,90 and 904. So you see that was the first one. Then the second one, they say the magnitude of C by using the sine rule. So now they are looking at the next one. They want me to find the magnitude of C, angle C, by using the sine rule. It's 2 marks. Now where do you get the sine rule? Back again to your formulas. You have the sine rule, and this is the sine rule, which says sin A over A is equal to sin B over B is equal to sin C over C. So I can use it here. I'll use it on the other side to say it's sin A. So they are interested in C. So, okay, let me just cut it first. It's sin A over A is equal to sin B over side B, which is equal to sin C over side C. So you see what I'm having here. But now they are interested in C. So I'm going to focus on my C, which is the last part of it, which is fine. So I take that, but I'm given, if you look at it, I'm given angle B. It's better to use the given angle, it's always wise. I'm given angle B and side B. So I can take these two together so that I will have, why am I using B? Because I'm already given B. I'm not going to rely on my answer. Sometimes using a wrong answer will mean a wrong C. So try to use the values that you're already given. So it will be sin B, which is 55, over side B. They told me side B was 27 from there, is equal to sin C over side C, and side C is 21 there. Are you seeing that? And then the next thing is to cross multiply like that, which is sin C times 27, which is 27 sin C is equal to 21 sin or sine 55 over 27, divide by 27 to have sine C. So sine C is equal to 21 sine 55 over 27. And then now to find angle C at that stage is arc sine the answer I'm going to get there. So C is arc sine the answer of 27 sine 55, 21 sine 55 over 27. See that? So I can even use that as is there to say shift arc sine fraction 21 sine 55, see that, over 27, then you put that in equal to 39,5772. So in 3 decimal places 39,577. So I've got C is equal to 39,577. So we can come here now and say my angle C here is 39,577. So as a person, you need just to check also. Remember, angles in a triangle, they must give me 180 just as a proof. So add all the angles inside and you must get 180. So if I add 39,577 plus 85,904 plus 55, if I add that, you see I'm getting 180,481 because of the rounding off, but you can see that it works towards 180, meaning I did my simplifications correctly. So that is how you're supposed to solve that. And we have got the last one. I think this is the last question because there is 3 marks, 24, and total is 100. So you see that this is the last part. Let's look at the last question. It says determine the equations of the following trigonometric graphs. You are given the 1 for 3 there. It goes here, it cuts at 45, it turns, I think it's turning at, so it started 3, I think this was supposed to be there, it turns at -3. So usually a graph that you must know this graph. If you start with a maximum, it's a graph for cos. So this is a graph for cos. The one that starts at 0 is a graph for sine. You understand? So you've got general form. This is for y2. So look at this. y2 is equal to a cos bx, because the graph for cos. I come down there and I do y1. I'm saying y1 is a graph for a sine bx. So my part is to find the a and the b's. So the a is the amplitude or where the graph is turning. You can see that here is turning at 3. So it is equal to 3 cos. Now I need to find b. So y2 here, let me write this right. So y2 is equal to 3 cos bx. I need to find 2 coordinates that I can use so that I can get now the b. And one part of the coordinate I can use is this coordinate. This is a 90 and this is -3. So when x is 90, y is -3. It's just that they were not putting it correct, but that is a 90. So where there is y2, I put, remember this is y, this is x. So where there is y2 is -3 is equal to 3 cos b 90. Seeing that, divide by 3, divide by 3. So if we divide that, 3 into -3 is -1 is equal to cos b 90. So what do I have there? How do I find that? So let me rearrange this so that I'll say cos b 90 is equal to -1. See that? So now come back to this. So what is this? Was rearranging. So if I say b 90 is equal to arc cos -1. So if you find arc cos -1, say shift arc cos -1, you get 180. So b 90 is equal to 180. I divide by 90. I divide by 90. You can see that b is equal to 2. So b is equal to 2. So my equation for y2, let me put it down there. y2 is equal to a, which was 3 cos b, which is 2x. So that is equation to 3. Y is equal to 3 cos 2x. So that is the part. I do the same thing that I did for y1, and I said it's similar. So I say y1 is equal to a, but it's for sine now, bx. Now where is it turning? You can see that it's turning here at 5, or it's turning down here at -5. So a's amplitude is 5, so y1 is equal to 5 sine bx. I also look for 2 coordinates that I can use so that I can substitute, and I can choose. You can see this coordinate there. So there is a 5 and 45. So when x is 45, this is my x. Y is 5. So x and y. So you see that that's what I'm going to substitute. So where there is y1, I have got 5 is equal to 5 sine b, and my x is 45. So again, divide by 5, divide by 5. So you have got 1 is equal to sine b 45, or 45b. Again, rearrange this such that you have got sine b in here 45 is equal to 1. So b 45 is equal to x sine 1. So when you do that, shift x sine 1, it gives me 90. So we have got b 45 is equal to 90 divided by 45 divided by 45. You can see that b is equal to 2. Also 45 into 90 gives me b is equal to 2. So when I write now my y1 is equal to, so y1 is equal to a, which is 5 sine 2x. So this is therefore my two they said determine the trig equations. So these are the trig equations for question 5.6. So this was the end of this paper. And now, just as a hint, avoid choosing, for example, you can see that there are some things I was avoiding. For example, avoid choosing where there is 0. For example, for sine here, the coordinates that I could have chosen, I can choose, I want to see where I was substituting. If I can come here and do this, let me play this back. You see the coordinates I was choosing, I chose 45 and 5, but let's say I wanted to choose a coordinate here which is 90 and 0. So in here you'll have 90 and y is 0. When you substitute that, you'll see that it will defeat the purpose because you're not going to get anything. So where there is y, I put 0 is equal to 5 sine b and 90. You see that? So divide by 5, divide by 5. Say 0 is equal to sine b 90. Sorry about that. So we are saying 0 is equal to sine b 90. So if I say like what I was doing to say b90 is equal to x sine 0. So if I use a calculator and say x sine 0, say shift x sine 0, this gives me a 0. So I've got b90 here. It's like b90 is equal to 0. Now you see we are dividing by 90, we are dividing by 90. You will think that b is equal to 0, so defeating everything. So this is not correct, because you are going to write your answer like what? You're going to say, remember the answer is y1 is equal to a sine bx. So your answer will be like y1 is equal to 5 sine 0x, which is not going to work. So avoid such. Use values that can give you the right value of p. So as I said, guys, we have come to the end of our lesson. I hope this was of assistance to you as you prepare for your final exams. I wish you all the best in your final exams. Remember, guys, after writing that exam, we always value your feedback. Send us feedback to say, how did you fare in that paper? Was this helpful? Did it assist you in your exam? Do you think there are some of the questions that we might also look into? Maybe you find that there are some questions that are not covered in this mathematics N3. There are a lot of videos here, but you might find that there are some questions that I haven't even yet covered. Send us those questions, send us those suggestions, and it will also help others as they are revising and preparing for their final exams. Remember, share this channel, subscribe if you have not done so, and it is something that gives us more motivation so that we can give more of these videos to you. Also, guys, if you are a person who says, look, I just feel like I need to assist you guys to bring more of these videos, we have got membership. There is membership that you can sign up for, and I think it's a contribution of a few rands. I think it's 99 rand a month, just to support this channel so that it can also be available for more and more, especially of those that cannot afford purchasing the videos. So you can become part of our fans, in a way part of our channel memberships, where there is a monthly contribution that can come towards maintaining this channel. We have come to the end of our lesson. Thank you guys.